this Cohen Sutherland's algorithm. So how this algorithm works means, see here, um, here for every endpoint of the line, you will calculate a 4-digit binary value, which is given by TBRL. So it is given by TBRL. For every line, you will consider the endpoint of that line and you will calculate this value TBRL, that is a 4-digit binary code. So based on the values of each bit, 0 or 1, it will tell whether it is inside the clipping window or outside the clipping window. So if all the bits corresponding to 0, it is inside the clipping window. If at least if it contains any one non-zero values, in this case, it is outside the clipping window. It is outside the clipping window, and that part of the line should be that should be clipped. So like that. So any non-zero value will give you an indication that the line is outside the clipping window. So four cases can come. It's like some lines are completely outside the clipping window, and some lines completely inside the clipping window, and some lines which are partially inside the clipping window as well as partially outside the clipping window. So using this Cohen Sutherland line clipping algorithm, we are going to remove the lines which are not part of the clipping window. Only those lines which will be within the boundaries of the clipping window, that line will be kept. So we will calculate the region code, and based on the region code, we will remove the lines. So for example, you can check here. For example, you can check here. This the endpoint of this P3 and P4. They are outside the clipping window, so this line will be rejected. The same with P9 and P10, and P1 and P1, it is completely inside, so it will be accepted. It will be completely inside, so it will be accepted. But P5 and P6, some part is inside and some part is outside. So here they will calculate the edge boundary. Here they will calculate the intersection point of this clipping window with this line, and they will configure a new point called P5 dash. So this point of intersection can be calculated by using the equation called y is equal to y naught plus m into x minus x naught, where m is the slope, where m is the slope, which can be calculated by the difference between the y points of P6 and P5 dash, like y points of y end minus y naught by x end minus x naught. So this will be the x naught, y naught, and this will be the x end, y end, like this. So if you want to find the point of intersection, that can be found out by using this y is equal to y naught plus m into x minus x naught intersection formula, and the slope can be found out by y is equal to m is equal to y end minus y naught by x end minus x naught. Similarly, if you want to find out x, means it can be calculated by x is equal to x naught plus um, y minus y naught by m. So this is the equation of the line. So what they're doing means y is equal to mx plus c, the equation of the line. They're just rewriting this line. So they're just rewriting this line of equation, and they're deriving this formula x is equal to x naught plus see, for example, if I move this line, this will become y minus y naught is equal to m into x minus x naught. Again, if I move this, it will be like y minus y naught by, sorry, if I move this, it will be y minus y naught by m. So x will become x naught plus y minus y naught by m, like this. So the equation, so the point of x and y can be found out best by this equation, line equation. So now let us solve the problem. So first thing is, here we are talking about the region code. Here we'll talk about the region code. Based on the region code itself, uh, we will eliminate some points. So whenever it is completely outside, we can directly eliminate them by considering the region code values of the points of the endpoints of the line. But whenever there is an intersection, you can also clip out the lines that doesn't become the part of this clipping window. And if you want to calculate the endpoints. Only when calculating the endpoints, you need this formula. You need this formula when you're calculating the endpoints. So, um, so let me remove this. Let me remove this. Now, how to apply this uh, Cohen Sutherland's algorithms for this problem. How do we apply that? So I'll just clear this and I will solve this problem. Just give me a minute. I'll just erase all these formulas so that we can solve the problem here itself. So the first part is I told you that the region code. So here region code we have studied from this table. So the first line tells that every line endpoint will be assigned a 4-digit binary value. So in our example, so this is my um, what do we call? This is my clipping window. So if I take this as the clipping window, so this is my clipping window. So this is my clipping window. So for this clipping window, I have points P1, P2. I have points P1 and P2. So I'll just write like this. So I'll just write like this. So this is my clipping window. So you can check here inside the clipping window, the bit positions, the line endpoint bit positions will be 0000. See for this P2, for this P1 and P2, P1 is having the values. The P1 is having the value. See, it is not on the, it is at the middle of the clipping window. So it is represented by TBLR. So since it is inside, since it is inside the clipping window, it is not on the top of the clipping window. So 0, it is not on the, it is not below this clipping window, so the bottom will also be 0. This point is not on the left hand side of the clipping window, so it is TBRL, sorry, it is TBRL. So TBRL, it is not on the right hand side also 0, it is not on the left hand side also. So for this point P1 is within the clipping window, so the 4-digit code is 0000. Similarly for point 2 also, so it is also below the it is also within the clipping window, like it is not, this portion is not top on the clipping window, so top will be 0, and again it is not below the clipping window, so 0, again it is not on the right hand side, and again it is not on the left hand side. So these 2 points are 000, so it is also non-zero value and it is also non-zero value. See all the bits all the bits, so there is no non-zero here, there is no non-zero, meaning you don't have any one, in point P1 end point and point P2 end point. So first what I did for this line P1 and P2, I calculated the 4-bit value, which we will call it as the region code for point P1. So this point is within the clipping window. So top will be 0, bottom will be 0, right will be 0, left will be 0. The same with P2 also. It is, since it is inside the clipping window, all the values will correspond to 0. Since these two digits, since these points, end points of this line P1, P2 doesn't have non-zero value, there is no non-zero value, it is understood that it will lie within the clipping window. So if I perform the AND operation, of P1 and P2, the result will also be 0. So first step, first calculate the region point, calculate the region code for endpoints of the line, So once if you calculate that, so the points within the clipping window, will have the region code 0000. So if all the 4 bits are 0, means it is in understood that the point is inside the clipping window. So what I did, I calculated the bit values, I calculated the region code, I got all the values as 000. So since all the values are 000, it is understood that the both the points are inside the clipping window. I performed the and operation of this results for this line point P1 and P2. Again, I got the output as 0, 0, 0 only. So even here also non-zero. Even there is no non-zero term here, meaning all in the result also all the values are zero. So so this point or this line given by the points P1, P2 will be accepted since it is inside the clipping window. So this point P1, P2 will be accepted within the clipping window. So this is how this point P1, P2 will get accepted. Any doubt here? See, in simple terms, I calculated the region code for the endpoint P1 and endpoint P2 for the line represented by P1, P2. I got endpoint calculation as 0, 0, 0, 0, 0, 0. It is a zero here. Every term in every bit is represented with 0, and it doesn't contain any non-zero value. Since it doesn't contain any non-zero value, it is understood that it lies within the clipping window. Also, you perform the AND operation of this P1 and P2. When you perform the AND operation of this P1 and P2, again you are getting the result as 0, 0, 0, 0. Even the result doesn't have any non-zero value. So it is clearly understood that the line lies within the clipping window. Since the line completely lies inside the clipping window, you need not remove that. So this is one of the simple case. This is one of the simple case. So the line is completely inside the clipping window. Accept that line. So don't trim that line. So this is one possibility. So this is one possibility. So now the second possibility. Second possibility, we will consider this line. We'll consider P3, P4. We'll consider P3, P4. So P3, for P3, it is on the left hand side. So P3, P3, TB, RL. So this line P3 is on the left hand side of the window. So L will be 1. So other parameters will be 0 only because it is not on the top side, it is not on the bottom side, it is not on the right side also. See, the other parameters will be 0. Similarly for P4, it is also on the left hand side of the clipping window. So it will be 1. The other cases will be 0. Again perform the AND operation. Again perform the AND operation. The result will be 1, 1, 1, 1. Sorry, 0, 0, 0, 1. So here it contains non-zero value. It contains non-zero value. So whenever you see a non-zero value in the endpoint values, it is understood that that point lies outside the clipping window, and also the result is also contains and also the result contains non-zero bit, and also the result and operation, once you perform the AND operation, the result also contains non-zero value at the same bit position of the lines. So P3 also contained 1 at L position, bit 1. This is bit 1, remember. So P3 also contained 1 at bit 1, P4 also contained 1 at bit 1, and the result is also having 1 at bit 1. So when when any line has 1 in the same bit position of both the endpoints, it is understood or it is guaranteed that the line will lie outside the clipping window. So see here, for bit at bit position 1, P3 is also having 1, P4 is also having 1, the result will be 1. So this line will lie completely outside the clipping window. So this line will be rejected. So this line will be rejected. So P3, P4 will be rejected. So similarly, if there was some line like this, if there was some line like P12, P13, so here for this, you would have got the R bit would have been 1. So this line will also be rejected. If there was some line here, means the top position would have been 1, and this line would have been rejected. The same with if there was one line, means the bottom position would have been 1, and that line would have been rejected. So we studied two cases. Case number one, where the line was completely inside. When the line is completely inside, we will get the non-zero values, and the output will also be non-zero when you perform the AND operation. So that line will be accepted. Case number two, we got non-zero value in the endpoints of P3 and P4, and again the result also um non-zero. So since the bit position is same, since the bit position 1 is there, since the bit position 1 is there at the same position as in case of the input, so it is understood that the line will completely lie outside the clipping window, and that line will be rejected. That line will be rejected. So so this is what is the next point. Any line, see, if both the endpoint codes are 000, the line is completely inside the box, so no need to clip them out. If the line has 1 in the same bit position, in our example bit location 1, so it is guaranteed that the line will lie outside the clipping window. And also we have performed the AND operation for both this points P3 and P4. So, and the result is not no 0, and the result is not 0, it contains one non-zero value, so this line will be rejected. So we have eliminated two things. We have eliminated two things. One is this line processing is done, this line processing is done. Now we'll consider case 3. Now we'll consider some cases. So now which one shall we consider? So now again, we will consider. Now again, we will consider this P5, P6. So we'll consider P5, P6. So for this is the case 3. So partial thing. So for this case 3, P5. So what is the region code? So P5. So top, bottom, right, left. So top, it is not on the top of the clipping window. It is not below the clipping window. It is not on the top of the clipping window. It is not on the one second. I'm just getting some call. Sorry, there was some interruption. So now we are talking about the next scenario, P5 and P6. For P5, first you find the endpoint region code for this. So you know that this point P5 lies to the left of the clipping window. So the left bit will be sent to 1, and other bits will be set to 0. And P6 P6 completely lies P6 completely lies within the clipping window. So for this all the values will be 0 0. So you will see one non-zero value is there in point P5, and all the values are 0 in point P6. You will perform the AND operation. So when you perform the AND operation, the result will be 0 0 0 0. So the result will be 0 0. But since in the input you have one point with non-zero value and one point with zero value, so it is understood that one point lies inside the clipping window and the other point lies outside the clipping window. So you have 2 points P5 and P6. So when you find out the region code for that, so what you're doing, for one point you're getting all the values as 0, and for the another point you're getting non-zero value. So if you perform the AND operation, the result is 0. But since one point contains non-zero value, it is understood that one value is lying inside the clipping window, and one end of the line is inside the clipping window, and other end of the line is outside the clipping window. So how to work on this scenario? So we understood this. Since P6 is within the clipping window, so this point will not be uh, like they won't clip this point. So for this point P5, for this point P5, 0 0 0 0 1, and it will be performed an AND operation with 0 0 0 0 to get the new points 0 0 0 to get the point position P5 dash. So we will see how to calculate this coordinate position x comma y. But here, how the processing is done. So they will take the point which is outside the clipping window. They will take the point which is outside the clipping window 0001 in our case, and it will be ANDed with the region code 000. So to get the points 000. So this for it is a new point. So this point they will call it as P5 dash. This point they will call it as P5 dash. So it is understood that P5 dash uh, P5 dash will have the region code 0000 because it is within the clipping window. The same thing. So like this, it will be handled. So uh, whenever 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 you get a points where whenever you get a line where one point is within the clipping window and one point is outside the clipping window, so the point which is having the value 0 will be left as it is, and for the point which is having the non-zero value which is outside the clipping window, that point will be ANDed with region code 000 to get the new point which it is named as P5 dash. So this is the third scenario. So the line will be from here P5. So the line will be from P5 dash to P6. So this is how the line will be counted. So after this, I'll just erase this. I'll just erase. Let me not erase. I'll write it somewhere. So now we'll consider the next point. We'll consider the next point P7, P8. So calculate the end position for P7, calculate the end position for P8. So um, now P7. So what is the region code for P7? Again, TPRL. So P7 is below the clipping window. So the bottom will be 1. The other parameters will be 0000. Okay. And P8 P8 is on the right hand side of the clipping window. Right side will be 1. The other values will be 000. So this also contains non-zero value. This also contains non-zero value. And the result is 000. And the result is 000. So now when both the endpoints, when both the endpoints, um, so what we did. So um, first thing is we calculated the endpoints for P7 and endpoints for P8. So we got P7 with non-zero value, P8 with non-zero value, and the outcome was 000, means some part of the line is within the clipping window, some part of the line is within the clipping window. So in this scenario how to implement this? So in this scenario, how do you solve this? Some part of the line is within the clipping window but the endpoints are outside the clipping window. So in this case you have to calculate 2 points which is given by P7 dash and P8 dash. So how to find that? So first thing is you should find the intersection point with respect to the boundary edges, and you have to repeat until the value will be 000. So they will take this point P7, they'll take this point P7. P7 is 0100. For this they will apply the out code as 00, and they'll perform the AND operation, you will get the result as 0000, and you will get a new point called P7 dash. You will get a new point called P7 dash. Again 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 what they will do, again, see, first thing is uh, take the point, perform the AND operation with the region code 000. You will get the 00, all the results are 00. So from this you will get one intersection point which I will call it as P7 dash. The same procedure will get get repeated again. So you can check P8. So again you can similarly for P8 also it is non-zero value. So if you can perform the AND operation with the outcode 000, you will get P8 dash. So the last part will be P7 dash, P8 dash. So this is how this clipping algorithm, so this Cohen Sutherland's clipping algorithm works. So you just look into these four cases. You just look into these four cases. After this, we'll solve how to get the intersection point. You just look into these four cases for a minute. Then we will solve the next uh, problem of finding the intersection points. Okay, so see one more thing which I wanted to tell. So here when how this scenario will work means, how this scenario will work means, I told you that um, P7, see P7 also non-zero value, P8 also non-zero value. So P7 you will take, you will perform the AND operation with 0, 0, 0, and you will get P7 dash. So again for P7 dash, it is given by 0, 0, 0, 0. Again you will perform, again you will find, see for P7 dash and P8 is the new line. So again for this you will calculate the endpoints P7 and P8. You will calculate the region code. For P8 it is 0, 1, sorry 0, 0, 1, 0, and for this the result will be 0, 0, 0. Now it will come under case 3. So 1 contains all the values as 0, and in P8 contains non-zero value. That means P7 dash is already inside the region code, but P8 is not inside the region code. So for this P8, take that P8 region code, perform the AND operation with 0, 0, 0. So get a new point which is P8 dash. P8 dash. Is this process clear? Whether you understood this problem? Yes or no? See whether you understood this problem or not. Yes, no, or any confusions? See, I need responses. So if you respond, then only um, we can proceed for the further lectures. So any doubts here? See, I'll just tell the steps which I've done here. See, first thing is find the endpoints. Find the endpoints of line. So, for example, P1, P2. If both the region code contains all the values as 0, 0, perform the AND operation. Perform the AND operation. Result is also 0. That means inside the clipping window. First case. Second case. Second case is P1 non-zero, P2 also non-zero. Result, so you'll perform the AND operation. Result is also non-zero. So now completely outside the clipping window. Reject, accept. Third scenario. Third scenario. P1 all the values 0. P2 all the some values are non-zero. So result is 0. See result in the sense I'll perform AND operation. So now this point is inside the clipping window. So leave this point. Take point P2. Take point P2 which is non-zero. You perform the AND operation with 0, 0, 0, 0. So the result will be 0, 0, 0. You'll get the edge intersection point. Case 4. P1 non-zero. P2 non-zero. Perform the AND operation. Result is 0. So in this case, some part of the line. Endpoints are outside, endpoints are outside, endpoints are outside this clipping window, but the line is crossing through the clipping window. So you have to find the intersection point. So first take P1, first take P1, N0, perform the AND operation with region code 000. You'll get the intersection point for P1 dash. So after this, take this P1 dash, which is which is 0. P1 dash will be now 0. Region code for that will be 0. Again P2, again P2, which is non-zero. You perform the AND operation. The result will be 0. So it will come under case 3. It will come under this case. Again in this, select the point which contains non-zero, which is P2 dash. Perform the masking operation with 0000. So you will get this intersection point, which you can call it as P2 dash. So these are the only 4 scenarios which you will encounter in um, Cohen Sutherland's algorithm. So this is regarding the edge selection. So this is regarding the edge selection. So what you have done, so this was the line. So this was the line. So I just go somewhere here. So this was the line which was passed before clipping. So after clipping, you can see the outside lines are rejected, and this part is trimmed, this part is trimmed, and this part is trimmed. So this is how the Cohen Sutherland's algorithm works. They will consider the region code for deciding which line to be displayed and which line to be eliminated. Any doubts here? Any doubts? Yes or no? Any doubts? Yes, no? Any doubts? So you just unmute yourselves and you just answer. Zenat, any doubts? Adesh, Akansha Kumari, Anant Krishnan.
Understood.
Okay. So now we'll solve one more problem where we'll find the point of intersection. Now we need, so in the last example, I was just marking the boundary edges. Now we'll solve one problem where you'll be finding the intersection point, where you will be finding the intersection point for this Cohen Sutherland's algorithm. So first I will draw the window. First I will draw the window. First I will draw the window. So the window size. So this is my clipping window. So this is my clipping window, which I'll name it as, it is starting at 5, ending at 9. So this is my clipping window, 5, 9, 9. So this clipping window is given by the size uh, 5, 6, 7, 8, 9. So 5 to 9. Here also it is 5 to 9, and on the at the top side also it is from 5 to 9. So now um, to be talking in terms of points, right? So now the clipping window, I've given the clipping window from 5 to 9. Um, so it will be like 5 comma 5. Here it will be y side, no, 5 comma 9, 9 comma 9, and it will be 9 comma 5. Sorry. Yeah, this is right. 9 comma 5. So like this. Here the x value. This is 5 comma 5. So sorry, this should be 5 comma 5, 6 comma 5, 7 comma 5, 8 comma 5, 9 comma 5. Okay, this is also right. 5, 6, 7, 8, 9. Okay, so this is the boundary of the clipping window. So I'm giving a clipping window with the range from 5 to 9. So it is having, the left hand side is at 5 comma 5, and the right hand side is at, now that is the starting point of the clipping window is 5 comma 5, and the ending border is the 5 9 comma 9. So after this I'm giving a line. There is one line, there is one line. So this is the, there is one line, there is one line which is passing like this. So there is one line which is passing like this. We'll assume that this line is having a point 8 comma 8. One end is at 8 comma 8, and the other end is at and the other end of the line is at some 4 comma 12. So it is at the other end is at the 4 comma 12. So we have this line. So we have a line given by the points 4 comma 12, 8 comma 8. So here we have one line with point p1 given by 4 comma 12, and the second thing, point p2, which is given by 8 comma 8. So now how do you solve the line clipping algorithm? How do you apply the Cohen Sutherland's algorithm for this? So for this line, for this line, it is on the top left, sorry, bottom left side of it is on the bottom left of the clipping window, and this is inside the clipping window. If I take this as P1 and this as P2, first thing is I'll perform the AND operation P1. So P1 is 4-bit code. It is on the bottom left. So TBRL. So TBRL. So bottom should be set to 1, and mm, bottom should be set to 1, and what else? Bottom should be set to 1, and it is on the left hand side, right? So it is on the left hand side. So I will call this as 4. So I'll call this as 4 2, because it is below the line. It is below the line. So below the line. No, 12 means it will go upside. So I'll just fix a point 4 comma 2. So 4 comma 2 means left hand side is also 4. Okay, this is fine. It is 4 comma 2. So this, what is the region code for this? It is on the left side bottom part. So top, bottom, right, left. So this will be my region code. This will be my region code 0101. For the point 2, for the point 2, it will be 0000, because it is inside the clipping window. So here you can verify the region code by checking this image. So here, what is the region code for this position? 0101. So they had given a window. See how to draw this means, this is my window. So this is my x value 5, 6, 7, 8, 9. So 6, 7, 8, 9. So now I want to point one point at 8 comma 8, 8 and 8. So this is one point. This is one end of the line. Again, I want to draw one more line at x given by 4. X given by 4 means x will be somewhere here, and y should be 2, 5, 4, 3, 2. So at this point, exactly at this point, so this is how I had plotted. So this is how I plotted this line. So if you just by looking at this, you can draw this line. So now, for first thing is I have to find out the region code. For the region code for this point P1 will be 0101, and the region code for this P2 will be 000. I'll perform the AND operation. So if I perform the AND operation 0000, I'll get. So since one value is non-zero and the other value is 0, one point lies inside the clipping window, other point is lying outside the clipping window. So now we should take this point P1, and we should clip that point in such a way that only those part of the line which intersects with the edge, the bottom edge of the clipping window should be considered. Meaning, we should get only this part of the line, and the remaining part of the line should be removed. So how to do this? So now, first calculate P1 and P2. So P1 contains non-zero, P2 contains zero value. So, and the output is also 000. So since the output is 00, the line is partially inside. The line is partially inside the window, and P2 is 00 means this point P2 is inside the window. So for point P2, don't calculate any new value. But for P1, it is outside because it contains non-zero value. So calculate the new value for P1. So for P1, since it is non-zero, we should calculate the new point. So how to calculate that? How to calculate the new point for P1? So I told you one formula. So one formula which we studied, um, what is the one formula which we studied? Y is equal to y naught plus m into x minus x naught, and m is nothing but difference between y minus y naught, sorry, y end by x end minus x naught. So here point P1. So for this P1 P2, calculate the slope. For this point P1 P2, calculate the slope. So y2 minus y1. So 8 minus 2. So point for point P2, point for this line P2 P1, slope is difference between y by difference between x. So 8 minus 2, 8 minus 4, it will be 8 minus 2 will be 6, 6 by 4. So you'll get the slope as around 1.5. You'll get the slope as uh, 1 point, you'll get the slope as 1.5. So once you find the slope, so once you find the slope, you have to calculate the line. You have to calculate the line y is the y point, that is a y intersection point, which is given by y is equal to y naught plus m into x minus x naught. So in our example, what is the value of x naught? X naught is 4. So x naught is 4. So I'll use 4 here, minus x into the value of the slope. The value of the slope is 1.5. So plus 1.5 plus 1.5, y is equal to y naught. So what is this y naught? Y naught is my initial value 2. So if you solve this, uh, if you solve this, you will get the value of x. And also here one more point, here one more point, here one more point, the line y, the line y, the line, see this is my, this is my this is my y coordinate, and this is my x coordinate. So here the line is intersecting, so here the line is intersecting at the x minimum position. So here the x minimum position is 5. So the line is intersecting at the position where the value of x is 5. So you should substitute for this value of x, you should substitute 5. So if you substitute, see that I mean the minimum window position. So x is given by x minimum. So yesterday I told one point. So you can check here. See, you will be calculating, you can calculate the values of this, where x you can replace with the x window position, and y you can replace with the y window position. So what we are doing means, once we find out the value, once we find out the slope, so we will substitute the x window position in order to find the value of y. So see, since the line is intersecting, so since in our case the line is intersecting at uh, x quadrant, so we have to find the x minimum position. If the line was intersecting, if the line was intersecting at this position somewhere here, means x maximum on the left hand side, x minimum on the right hand side, it will be x maximum. You just substitute the value of x minimum here. In our example, x minimum is 5, so it will be like 5 minus 1 will be 5 minus 4 will be 1. So 1 into 1, 1.5. So 2, the y point will be somewhere around uh, 3.5. So 3.5 means you can round it off to 4. So y position. So the value of the y, you are getting it as 4. So 4 means somewhere here, somewhere here. So once you get this, this will be your new point. So the new point will be uh, the new point will be what is my new point? 4 comma 4. So my new point will be 4 comma 4, somewhere near to this, somewhere near to this uh, intersection points. So sorry, I've taken this x as 5. No, since I've taken x as 5, my new point will be 5 comma 4 somewhere here. So somewhere here 5 4. So again again you should repeat the same procedure to calculate intersection point this intersection point. So I'll just repeat this process. So I'll repeat this process again. I'll just repeat this process. So see what I did. See what to do means the first thing is calculate the endpoints. So calculate the endpoints P1, P2. So calculate the endpoints P1, P2. So after that, if the result is if any one of the input contains non-zero, it is lying outside the clipping window. So in order to find that, first in order to find the intersection point, first find the slope. First find the slope. Since it is intersecting at the left hand side, so that you have to take the x minimum value. So the x minimum is 5 in our example, in our case, because the window is starting at the position 5. So x minimum will be 5. So considering this x minimum and calculating the slope, we should find the value of y. So then you will get the point. Then you will get the point still which is outside the clipping window. Since it is outside the clipping window, the same process should be repeated. Since it is outside the clipping window, again the same process should be repeated till you find this intersection point. So I'll just clear this. I'll just clear this and I'll just clear this. One second. I'll just clear this point and we'll repeat this. So since we have only 5 minutes left, I'll solve this problem again in the next class also. See, one more calculation is to be done. You just try to find the intersection point. So the procedure is same. Calculate the points, calculate the slope, substitute the window position, the clipping window value in place of x and get the y value. So the same problem I'll just repeat in the next class, and then we can proceed with the polygon clipping algorithm. So I'll stop the class now. In the next class we will see this problem again. So one more step is there. So we have found the one intersection point. If we repeat the same process, we will get the actual intersection point. So you just try this problem now. If you're not getting, we'll check again in the next class. I'll stop the class now.